All right, we are going to work on the Chapter 7 and Chapter 8 practice tests together. So I promised you guys an answer video, and well, here it is. All right, so hopefully you've already read this question. I'm just going to quickly go over the answers and kind of explain why they're the right answers. So for this question here, we're increasing sample size of voters from 1,500 people to 2,500 people. The biggest effect of this is going to reduce the variability of the estimate, because you should remember from class, as n goes up, we know that sigma, or variability, goes down. All right, so that's actually one of those pretty easy questions, so we'll move on from there. Number 2, so this one is going to be asking you what are the mean and the standard deviation for the sampling distribution of the sample proportion. So you got to think back to Chapter 7. This is section 7.2. When we're talking about the mean of p hat, it's going to be equal to p, and the standard deviation of p hat is going to be equal to the square root of pq divided by n. All right. So when we're talking about the the magazine Sports Illustrated asked a random sample of 750 Division I college athletes, do you believe that performance-enhancing drugs are a problem in college sports? Where 210 responded yes. All right, so we know there that that's going to be p hat. It's going to be 210 out of 750. So that's going to be your sample proportion. Now, that's often going to be confused within your answer choices as the actual proportion. Here, you guys should read that suppose that 30% of all Division I athletes think that these drugs are a problem. That's actually going to be p. So p should be equal to 0.30. So it's going to be a trap answer here if you guys choose to use p hat for this problem. So notice here that a lot of the answer choices involve 210 out of 750, and if memory serves, that's going to be your 0.28. So you can go ahead and mark those two answer choices out. Additionally, you can mark out 210 for answer choice E because it's not a proportion. It's just a number 210. So we're down to C and D here for this one. So if we were going to follow these formulas here that we learned earlier in Chapter 7, we know that this should be 0.30. So if the mean of p hat is equal to p, given that it's an unbiased estimator, we should know that the mean of p hat should be equal to 0.3. So that leaves C or D, but the standard deviation is different. So you can look at the standard deviation formula here. In Part D, this is not how we compute the standard deviation of a sample proportion. We compute that as the square root of 0.3 times 0.7 divided by the sample size, which is 750. So answer choice here should be clearly C. Part 3 here, number 3, is going to be a newborn baby who has an extremely low birth weight, ELBW, if it weighs less than 1,000 grams. A study of health of such children in later years examined a random sample of 219 children. Their mean weight at birth was X bar equaling 810 grams. This sample mean is an unbiased estimator of the mean weight mu in the population of all ELBW babies. All right. So if we know it's an unbiased estimator back from Chapter 7, this is 7.3. Unbiased estimator here so that means that the mean of all X bars should be equal to mu, which should be equal to the X bar that we get. All right. So we don't necessarily know that this is equal to mu. We don't know that. But we do know that should be the mean of X bar, which should be equal to mu, which should be equal to the X bar that we get. So it means it should be very, very close to that. All right. So for this answer choice, B is going to be the best. Now, I know a lot of you guys might confuse that with Part A here, because in all possible simple random samples of 219 from this population, the mean of the values of X bar will equal 810. Well, that's for the sample. Remember, we're talking about the true population mean. We don't know that 810 is the population mean, but if we do this over and over and over and we get a mean of all the X bars, which is equal to 810, well, that should approximate mu. So that's what makes this answer choice better than this one, because we don't actually know the mean population. We probably should do something like a confidence interval to estimate it, but that's going to be the difference between A and B. Hopefully that made sense. Number 4 here, you're going to be asked to identify which of the following statements is true here. So a school administrator is interested in estimating the proportion of the students in the district who participate in community service activities. So right off the bat, you should know that you're estimating a proportion. So this means that you're talking about estimating P equals. And we're probably going to have to use P hat. So if you're talking about a confidence interval, which I'm just kind of browsing some of the words down here in our answer choices, remember that this is going to be using a 1 proportion Z interval. So this is a 1 proportion Z interval. So they took a sample of 100 students at random in the district, and the administrator will construct a 99% confidence interval for the proportion of all district students who participate in these community service activities. So which of the following is true? Answer choice here, you should have actually picked D. The probability that the confidence interval will include the population proportion is 0.99. All right, so that's kind of like almost, I need you to think of like the C part of panic when we're talking about estimating where we think that the true population proportion will lie. So we have a 99% confidence. So the probability that it will include this population proportion is going to be 0.99. Now, remember, a lot of you guys might try to choose C, but remember, the probability that it includes the sample proportion is going to be not 0.99, but actually 100%. Because remember, the sample proportion helps construct the confidence interval. We have no idea what the population proportion is, so we cannot infer that it would be equal to the sample proportion. The probability that those two things would be equal is 0.99. Again, we do not know that, all right? And it would be kind of silly for us to say there's a 99% chance that the probability that those two things are equal. Remember, generally when we're estimating with confidence, we have a p hat kind of in the middle of your interval. You go out to a long end, so that means when we add the margin of error, and then over here when we subtract the margin of error, and we get bounds. So we know that P could be somewhere in there. I mean, it could be here, it could be there, it could be outside. But remember, will we ever know if it's inside or outside? Answer is no, we never know, right? So here, we can't say that there's a 99% chance that they're equal. And then the population portion will be in the confidence interval. That is going to be false as well, because we just kind of highlighted that. We never know if it's actually in or outside the confidence interval. That's why it is answer choice D. Moving to number 5, this one is going to be a setup of a z-score for a sample proportion kind of idea. So here, the big idea is that you need to remember how to differentiate P from P hat and how to set up a z-score for a sample proportion. Okay, so first thing, z-score for a sample proportion, P hat minus P over square root of PQ divided by N. All right, so that's going to be the statistic. Remember, this is a statistic minus the parameter, and that's divided by the standard deviation of the statistic. Okay, so when you read this problem, I need you to locate what P is, what P hat is, and also what the sample size is. Now, looking from our answer choices, it looks like the sample size is going to be 300. All right, and it looks like we need to discern if it's going to be 0.22 as P or 0.22 as P hat. So then that 0.27 is going to be one or the other. All right, so according to government data, 22% of children in the United States under the age of 6 live in households with incomes that are classified at a particular income level. A simple random sample of 300 children in the United States under the age of 6 was selected for a study of learning in early childhood. If the government data are correct, which of the following best approximates the probability that at least 27% of children in the sample live in households that are classified at this particular income level? So the 21 or 27% of the children in the sample is going to definitely be your P hat here. So that's going to be your 0.27. So our statistic should be 0.27, which means that our P, I wrote those backwards. This would be 0.27. So it means our P is going to be 0.22. So I hope that you guys see the difference there. So 27%, I guess I actually should have done this in blue to be consistent, right? But the 27% are coming from the sample. So that indicates it's going to be a P hat. All right, so what's the difference between some of these? Well, if you can come over here and take a look at the answer choices here. So I'm going to move that over. Look at the answer choices here. E is definitely not going to be it, and D is definitely not going to be it, because I think they switched the statistic with the parameter. So if 27 had been our parameter and 22 had been our statistic, those would be true. So we're down to A, B, and C. So what is the difference here between A, B, and C? I think it comes down to using the proportions to estimate the standard deviation of your statistic. So remember, we need to focus on this piece here because all of them do 0.27 minus 0.22, which is going to be the correct setup of the numerator. So the denominator here is what separates these three answer choices. Remember, if we know P, we should use P. Do we know P? Yes, it's 0.22. So which of these three have 0.22? Then the complement of that on the denominator, so it should be 0.22 times 0.78 over 300. So that looks like answer choice B. So you should have chosen answer choice B. Right? Looking at number 6, here you're asked to figure out the minimum sample size. All right, so we're talking about a minimum sample size. So this means that we're going to use a margin of error. And I'm already kind of seeing the words margin of error located up here in the stem of the question. But let's see if we're talking about one proportion Z interval or one sample T interval. A large newspaper periodically reports the mean cost of 2 people, or for 2 people at restaurants in the city. You can stop reading there to figure out if it's a one proportion Z interval or one sample T interval. As soon as you saw the mean cost of dinner for 2 people, this is going to be a one sample T interval. Do recall here that when you're trying to find sample size for a mean, generally they're going to have to give you the population standard deviation. So let's keep reading to make sure that we actually might not need to use T, but in fact we might need to use Z. So let's take a look. The newspaper staff will collect data from a random sample of restaurants in the city and estimate the mean price using a 90% confidence interval. So I'm going to underline 90% confidence interval because we might need to come back to that. In past years, the standard deviation has always been very close to $35. Assuming that the population standard deviation is $35. So ladies and gentlemen, they give you here that sigma must be 0.35 since it has always been very close to that. So here, that's why we're going to use Z and not T. All right? So we need to figure out for the margin of error here, it's going to be Z star times sigma over the square root of n. Remember, the margin of error for a one sample T interval, or in this case, a one sample Z interval, is going to be the crit value times the standard deviation of the statistic. All right, so we have sigma's $35. We want to find n, so we're not going to know what that is. Because if we know that the population standard deviation is $35, which of the following is the minimum sample size needed to attain a margin of error of no more than 5? Okay, so we need to figure out what Z star is, and we need to figure out what the margin of error is. Well, margin of error we just read. That's got to be no more than 5. So what is Z star? Well, remember, we talked about this 90% confidence up here. So for 90% confidence, critical value is 1.645. That's one of the big 3 that you should have memorized. All right, let's substitute these values into my formula here. So I'm going to substitute these values in. So margin of error is going to be $5. That should be less than or equal to 1.645 times sigma, which would be 35 over the square root of n. All right, we do need to simplify this a little bit. I'm going to grab my calculator, which is over here. So 1.645 times 35. So let's do that real fast. 1.645 times 35. And that gives me less than or equal to, this should be 57.575 over square root n, which is equal to 5. All right, then remember we can switch these. So I'm going to multiply the square root of n over there. And then this divides. So the square root of n is going to be, let's actually change this to be equal to. I think some of that might confuse you guys. So get that times 5, which is equal to 57.575. All right, divide both sides by 5. So I have square root n is equal to, well, divide that by 5 should give me 11.515. Sorry about my terrible 5s, guys. And then what we're going to do now to get rid of that is square both sides. So we're squaring both sides. So n is going to be equal to that squared. It's going to be 132.595. So that means should be at least or more than 133 people. So taking a look, you guys see that 133 is up here on the board as answer choice C. Right? All right, for number 7, it asks us which of the following is the best interpretation of the interval. So we're interpreting the interval. Now that was different than level, so you got to actually know how to do both. So I encourage you guys to look after the first day of 1 proportions the interval, there was a free response about the Humane Society. That's how to interpret a level. You guys should be able to interpret a confidence interval in your sleep. This is the we are 95% confident that the interval must capture the true mean or true proportion of whatever context here. So as you kind of glance at some of these multiple choice answers, A, B, and C should be automatically marked off, all right? Because which ones are actually in kind of like the form that we use? We are 95% confident that the true mean is between this and this. Well, not for a randomly selected time. We're not talking about a randomly selected time. We're interested in what the true mean or the true proportion is. So that has to be answer choice D here, all right? So remember that this is basically like the C part of panic that we're doing in terms of multiple choice answers. Moving ahead to number 8, we have a question about researchers who will conduct a study of television viewing habits of children. They will select a simple random sample of children and record the number of hours of television that the children watch per week. The researchers will report a sample mean as a point estimate for the population mean. So again, this word point estimate, remember this is a single statistic that attempts to estimate the parameter, okay? So here, my sample mean x bar is attempting to estimate my population mean mu. Which of the following statements is the correct for the sample mean as a point estimator? And it looks like each of these answer choices is comparing a sample size 50 to a sample size 100. So remember, if you're going to go from n equals 50 all the way to n is equal to 100, you got to think about what you're doing here. That's a terrible arrow, by the way. That's a little better. So if you're going from n equals 50 to n equals 100, you are increasing the sample size. So what's happening as an effect? So if you increase sample size, remember that the first thing you should think of is that variability should be going down. Notice that some of these answer choices are talking about variability. Now, we don't know anything about the bias here. So here's the thing. If it's talking about increasing sample size, remember that increasing sample size is not fixed bias. It only reduces variability, right? Or on the other end, if you decrease sample size, it increases variability. So one of those two things is going to go on. So take a look at the answer choices. What's the best one? I would say the one where 50 is going to 100 and decreasing the variability. So size 50 will produce less variability. No, it's going to produce more variability. So based off the wording of the question, A is going to be the best answer because it's actually definitely confirming this idea here. Okay, that it's going to have more variability than a size 100. Again, why is it not E's, D, or C, E, and D? Because they're talking about those being bias estimators. All right, and remember, if we increase the sample size, that is not going to make it bias. Bias has to be fixed by redesign of a sample or talking about your survey questions in a different light, maybe doing some careful field testing and wording of questions. Here, that sample size is not going to affect the bias, but definitely the variability. Number 9, this one is a fantastic question. Of the study guide, this is probably my favorite question. A quality control inspector will measure the salt content in milligrams of a random sample of bags of potato chips from an hour of production. Which of the following will result in the smallest margin of error estimating the mean salt content mu? You want small margin of error. So what is going to be the smallest margin of error? So if you want to shrink your margin of error, the first thing that you need to know is that smallest margin of error means that variability is going to be low. So if your variability is going to be low there, you need to think about how sample size is going to play an effect. Well, we've been talking about it throughout the review. Sample size will have to be high. Sample size will have to be high. Also, smallest margin of error means that your confidence level will have to be the lowest, okay? So remember that if you're talking about an interval that is 90% confident, that's going to be less wide than a 95% confidence interval. Remember, the more confident you are, the bigger your head's going to be, right? And really cocky people, really confident people have big heads, right? So the more confident you are, the bigger the interval is going to be, which means, in turn, you're going to have a larger margin of error, okay? So here, we want small confidence, high sample size, small sigma, or small standard deviation. Taking a look at this, first thing that sticks out to me is this, the size 100. That is the largest sample size there. Of those choices, does it also have the lowest confidence level? Yes, at 90%. This one's going to produce the smallest margin of error. The ones that are going to produce the biggest margin of error are high confidence, low sample size. So here, this one is the opposite. So this one has the largest margin of error. So 99% confidence has this wide interval, and it's also going to have a lot more error because of the low sample size. So I hope you guys see the things that you need to look at to help you determine it. Okay? All right, last question for the multiple choice. One reason for using the t-distribution instead of the standard normal curve to find critical values when calculating a level C confidence interval, where C represents the desired confidence level, is, remember, why do we use t over the normal curve? This is generally when we talk about a one sample t interval. Something is missing. And that something that is missing is sigma. If sigma is missing or is unknown, that means that we're going to switch to t. So this one, sigma is unknown versus sigma being known. All right, so before I even looked at the answer choices, I knew that the reason that we use t over z is because sigma is unknown. So take a look. The answer choice here you should definitely be looking at is B. Z requires that you know the population standard deviation. All right, pretty easy, as long as you know the relation. All right, moving forward into the free responses. The amount that households pay providers for access to the internet varies quite a bit, but the mean monthly fee is $28 and the standard deviation is 10. The distribution is not normal. Many households pay $10 for limited dial-up access or about $30 for unlimited dial-up access, but some pay much more for faster connections. If a sample survey asks a simple random sample of 500 households with internet access how much they pay, let X bar be the mean amount paid. So first question here is, explain why you can't determine the probability that the amount a randomly selected household pays for access to the internet exceeds $29. When you're talking about a randomly selected household, you're not talking about the average of those households over the time. So that's not incorporating. So this is not connected with simple random sample of 500. So those are not connected in any sort of way. All right, so here, when you're talking about a randomly selected household, you have to use the population distribution. And you know that that distribution is not normal, okay? So if you want to take a look at the answer, I will kind of mimic that up here. So for one part A, since the population is not normal, we cannot determine the probability of a single randomly selected household. that pays over $29 for internet. All right, go ahead and pause the video there if you need to jot that down, but I hope you understand why. It's talking about a randomly selected household and not a mean. All right, so not going to work there. All right, in part B, you're asked to describe the shape of the sampling distribution of X bar. So justify your answer where needed. Okay, so remember, the sampling distribution accounts for the simple random sample of 500. So first thing you want to talk about here is when you're talking about describing the shape, you should be using SOX. First, you need to talk about the approximately normal shape. A lot of you guys struggle with this concept about this being approximately normal, but remember here that n is going to be equal to 500, which is much larger than 30. So using the central limit theorem allows us to say that the sampling distribution of X bar is approximately normal. So remember, if you're going to name drop the CLT, you need to at least talk about how that's going to be working. So this is how you're going to talk about the shape. Now the center here, again, we're talking about the mean of all the X bars. Now, assuming here that it's approximately normal, this should be an unbiased estimator where the mean of all the X bars should be equal to mu. So from up here in the problem, you know that the monthly fee is $28. So that means here that this is going to be equal to $28. So we're going to have a mean of in a center of $28. Now 3 for spread, remember you're not going to talk about the high variation, low variation. Like you don't have a graph. You know it's approximately normal shape, but you don't have a graph. So here you need to talk about sigma sub X bar. And remember, that is calculated by taking the standard deviation and dividing by the square root of your sample size. So here, that's going to be $10 over the square root of 500. Now, that's going to give you approximately 45 cents if you do that. Okay, so you got to make sure here that you divide by the square root of the sample size when talking about a sampling distribution. So please check the work that I already have on Canvas for the practice test for the statement. So you should write one statement here that kind of blends all this together. So that statement should be that the sampling distribution of X bar or of this distribution is going to be approximately normal with mean of $28 and standard deviation of 45 cents. Right? We're actually going to use that information now to answer the last part of this question, which is to try to find out what's the probability here that the average fee paid by the sample of households exceeds $29. So the average fee paid by the sample of households will exceed $29. The average fee paid exceeds 29. So this is not a single observation. This is the mean. And you're trying to find out if the mean average is going to be greater than or $29. So what we need to do here is, this is when you're going to have to compute a z-score. So our z-score for sample means should be X bar, subtract mean, divided by standard deviation over the square root of n. Now here, this X bar is going to be $29. So that's going to be $29 there. We're going to subtract out the mean here, which is going to be $28. And then our standard deviation here should be divided by, we already computed that, that's that 45 cents that we computed. All right? So make sure you have each of those. Finally, if you find the z-score, I'm going to calculate, that should be 1 divided by 0.45, so that should be approximately 2.22 repeat. If you wanted to use that as a fraction, that is 20 over 9, whatever you want to do. Over here to the side, I'm going to do the work for this. So mean here in the middle, we're going to be talking about moving this. I'm going to move that little thing over. We're over here at 2.22, and we're talking about this probability to the right. Okay, so using your normal CDF button in your calculator, that should give you your 0.0131 probability. So making some statement about there is a 1.31% chance that the average fee paid by the sample of households exceeds $29 would be fantastic to wrap this up, but that's how you do the probability calculation, right? Students lose track here. This is it, right? This is the issue that a lot of you guys have when calculating probabilities. So hopefully this helped a little bit, right? Moving on, we're going to go to free response number 2. In January 2010, a Gallup poll asked a random sample of 1,025 adults, in general, are you satisfied or dissatisfied with the way things are going in the United States at this time? In all, 256 said that they were satisfied. We're going to construct and interpret a 90% confidence interval for the true proportion of adults who are satisfied with how things are going. All right, so this means that we're going to do a complete panic. I'm going to do a complete panic, start to finish. So if you guys do need some review here, let's go ahead and do it. First thing you need to decide is, am I doing a 1 proportion Z interval or a 1 sample T interval? It literally tells you what to do. We're constructing this for the true proportion of adults who are satisfied with how things are going. So this means that we're going to be constructing a 1 proportion Z interval. So for P, we are going to say we want to estimate P equals, and this is going to be the true proportion of adults who answer they are satisfied with how things are going with 90% confidence. All right, ladies and gentlemen, this will give you full credit for the P part of panic. So that is P. Next part we're going to do is part A. So here is going to be our assumptions. It is very, very important that you check your assumptions. Here for a 1 proportion Z interval, there are going to be 2 main ones. First one, you need to think about if we have a random sample going backwards. Do we have a random sample, random assignment, simple random sample? From the STEM, it says we have a random sample of 1,025 adults. Very, very important that you see that and not confuse that with a simple random sample. That does matter. So here, first thing we're going to say is we have a random sample of 1,025 adults. Second, we need to check normality. We need to assess the normality. So again, this is not where n is greater than or equal to 30, okay? We're talking about proportions. The way we check normality for a 1 proportion Z interval is to see if NP hat is greater than or equal to 10 or NQ hat is greater than or equal to 10. All right, so given that our sample size is 1025, also over here, I need to go back. Given the STEM here, we know that 256 said that they were satisfied, so the number of successes here is 256. So we know that 256 is greater than or equal to 10. We also do know that the failures are going to be greater than 10, because that would be 256. Subtract that from 1025 is 769. So that's greater than or equal to 10. Therefore, we know that the sampling distribution of P hat is approximately normal because there are at least 10 successes and failures. Okay. So I'm going to erase this P part because we're now going to do the NIC part. So N we're going to name our procedure a one proportion Z interval. For I, we're going to state the formula. You guys should have memorized this as p hat plus or minus z star times standard deviation, which is p hat q hat over n. Oftentimes students ask, when do you use p hat and q hat versus p and q? I always tell them, if you know p, use it. If you don't, use the next best thing, which is p hat. All right, so from before, going back over here, 256 out of 1025 is going to be your sample proportion. So at this time, what I would like you to do is to take out your graphing calculator, and I'm going to actually show you how we can use that work plus the formula and kind of blend this all together. All right, so here's the screen on your calculator. You're going to go to stat, and then you're going to go all the way over to tests, and then you're going to look for the one that says one proportion Z interval. So you're going to go all the way down until you get to letter A, and you're going to notice that letter A there says one proportion Z interval. Go ahead and press enter there, and you're going to ask for three things. So you're going to ask for X, N, and the confidence level. X is the number of successes. From the problem, we know that there were 256 successes. Those are the people who said that they are satisfied with how things are going. Total sample size is 1025. So you know that's out of 1025. We know we're attempting to figure out a confidence level of 90%. So we're going to change that to 0.90. We're going to go down, and then we're going to hit calculate. And guys, that is how easy this is going to be for you to calculate this proportion. Now, you do need to recall that you have to write down some work with this. So we already have our formula ready, good to go. We're going to use this interval to kind of, explain like how we actually need to estimate this proportion. So let's use this information. Using your formula here, so we're going to say that this is 0.25, because from our calculator, we noticed that it was pretty much approximately 0.25, so we're going to round up a little bit. Plus or minus, we know that this is going to be 0.25 times 0.75 divided by 1025. Z star should be, for 90% confidence, again, one that you have to memorize, 1.645. The confidence interval from our calculator said that this was approximately 0.228 to 0.272. All right, so for this one, we are ready to finally end it with our conclusion. So remember, the whole point of confidence intervals is to estimate where we think the true mean or the true proportion lies. So for our interval conclusion, we need to say we are 90% confident. That's how confident we are in our estimate. That the interval we constructed from 0.228 to 0.272 captures the true proportion of adults who answer that, quote unquote, they are satisfied with how things are going. All right, and you have finished your confidence interval. Okay, so I hope that helped. We're going to go back to part B, or back to the thing to back to the question to look at part B. So part B says, suppose that you want to have a margin of error no more than 0.02. How many additional adults? Now that's a very important thing. How many more adults would you need to do this? So what we're going to do is we're going to figure out how many adults we need total, and we're going to subtract what we currently have from them. I think you might see what we're really talking about once we do it. All right, but we're talking about a margin of error of no more than 2%, or 0.02. All right, let's go back over to the screen. And we're going to do part B. So part B is talking about the margin of error. So from class, you guys should remember that I am not very good at erasing this apparently. There we go. So part B, you guys remember from class that we talked about the margin of error formula, and that's constructed of two things. Z star, our critical value, times the standard deviation of the statistic, P hat, Q hat over N. So from our problem, what do we know and what do we not? That's what we need to figure out. So do we know the margin of error that we want? The answer is yes. We want that to be within 0.02. So we want to put 0.02 there. So 0.2. Z star. We have 90% confidence. We know our Z star should be 1.645. So we knew our Z star, given 90% confidence level, is going to be 1.645. All right, for P hat, did we know P hat? The answer was absolutely. We actually knew our P hat. Remember, if we don't, we use 0.05. But here we do. So we're going to use 0.25, to talk about P hat. So this should be P hat is 0.25. Remember that Q hat is 1 minus that, so that should be 0.75, all divided by our sample size, correct? All divided by the sample size. Remember, first thing we're going to do to get rid of this is I like to square everything. So square, square, square. Remember the square root and the square divide. So this becomes 0.02 squared equals 1.645 squared times whatever the product of 0.25 times 0.75 is. And I'm going to do that quickly. That should be 0.1875. And all of this is going to be divided by n. All right, so all of that is going to be divided by n. Now, what we're going to do is we're going to solve for n. Remember, the easy way to do that is to switch n and the 0.02 squared. So n is going to be equal to 1.645 squared times 0.1875, all divided by 0.02 squared. All right? What we're going to do now is we're going to switch over to the calculator real quick, and we're going to put that in. All right, using our calculator, let's do alpha y equals, and then numerator, denominator. So we're going to do 1.645 squared, and we're going to times that by 0.1875, and then we're going to divide this by 0.02 squared. All right, and that's going to give us the rough approximate sample size here. So we get 1268.449. Remember, we always round up with sample size. So we're looking for 1,269 to be the sample size that we need in order to achieve that margin of error. So let's go figure out how many more people we need to sample. All right, so we have n is equal to 1269. Now, remember that the question asked, how many more additional adults? Well, we've already sampled 1,025. We need to take 1269, which is what we need, subtract out the 1,025 that we have. So that should give us approximately 244 additional adults needed. So that's going to be your answer to part B. Hopefully that little explanation helped out. All right, let's move to the last free response question here. This one is a free response from the 2013 AP exam. This was number 1, so this was the first question, usually a pretty easy one. Pretty rare that you guys start off with a panic question, but let's see how this one goes. So an environmental group conducted a study to determine whether crows in a certain region were ingesting food containing unhealthy levels of lead. A biologist classified the lead levels greater than 6.0 parts per million ppm as unhealthy. The lead levels of a random sample of 23 crows in the region were measured and recorded. The data are shown in the stem plot below. Part A asks you what proportion, basically what percent, of crows in the sample had lead levels that are classified by the biologist as unhealthy. Well, the biologist said anything greater than 6 parts per million was unhealthy. So going to the stem plot up here, you should notice that there are 4 observations where we would classify this as unhealthy. So 4 observations where this is unhealthy. So we know 4 are unhealthy out of the total, which is 23. So this would be the equivalent to 0.1739. 1739. And that's it for part A. So that's a pretty easy question. The reason that this is going to be a panic is for the next statement. It said the mean lead level of the 23 crows in the sample was 4.9 parts per million and the standard deviation 1.12 parts per million. Construct and interpret a 95% confidence interval for the mean lead level of crows in the region there. So we're going to slide over to the next slide, and we are going to do a panic. So first thing we're going to do is understand that for our parameter P, we want to estimate mu. I hope you understand why we're switching from P to mu, because this is talking about the mean lead level of the crows. All right, so we don't know how much the true mean is, all right, but we do know that the sample mean was 4.9 and standard deviation of 1.12. So mu is going to be the true mean lead level of crows in the region. We're going to do this with what percent? 95% confidence. All right, next part is A. So again, one of the major differences between a one proportion Z interval and a one sample T interval are the assumptions. Remember, there are going to be three that you check for the one sample T interval. First is the same uniform amongst every single inference procedure, and that is going to be random sampling or random assignment or simple random sampling. Going back to the stem of the question at the top, we should note that we had a random sample of 23 crows in the region, not a simple random sample, a random sample. So please make sure that you note that. Oh, whoops. Let's go back over. All right, so number one here, should we have a random sample of 23 crows? Two, we need to check the normality. So here, so for normality, notice that our sample size is less than 30 because we have n is equal to 23. So generally, this means that we would have to graph the individual data. However, if you guys remember, if it's already graphed for you, remember, this is a nice stem plot. You guys see this lovely stem plot. It's graphed for you, so no need to graph it again. You guys got to remember here is, take a look, and I'm going to kind of draw a density curve around it, if I could draw it correctly. Now I want you to ask yourself, does this meet a qualification of saying that this is approximately normal? Well, do I see a single peak bell-shaped symmetric curve? The answer is yes. Because it is a symmetric single peak bell-shaped curve around that, we can assume that the sampling distribution will be approximately normal. So let's write what we did there. So we would say since the stem plot is approximately symmetric, with no outliers, we can assume the sampling distribution of X bar is approximately normal. Right? Part 3, we need to talk about sigma is unknown. So we're going to use S of X to estimate. Remember that we know that the sample standard deviation is going to be 1.12. That is not sigma. Remember that this here leads us into our n. So remember that our n for this is going to be naming the test. So we're going to name our test as a one sample t interval. All right, first thing you need to do is write down the formulas. That's going to be x bar plus or minus t star times, again, we don't know sigma, so we're going to use S of x divided by the square root of the sample size square root. All right, so remember from the stem, you already know the sample standard deviation. You were given that as 4.9, so I'm going to plug that in there. We also know the standard deviation. We know that's going to be 1.12 divided by the sample size we know is 23 because all of this information was given to us. The only thing we don't know is going to be T star. So remember, we're going to use our calculators to do that. Right? So grab a calculator. I'm going to take you through that calculation. All right, to find T star, remember to use second vars, and we're going to go down to number 4. So we're going to hit inverse T here, not inverse norm, inverse T, because we're going to use those T procedures since sigma is unknown. All right, remember that you need two things. Oops. You need two things to do inverse T. You need degrees of freedom, and you're going to need, I'm kind of frozen for a second. Does it let me type in? Oh, yeah, it does. That was weird. Anyways, we're going to need area under the curve and degrees of freedom. Remember, we're talking about a 95% confidence interval. So in the middle of this, we're talking about 95% confidence interval. So that means that all this area here is shaded. All that area there is shaded. Over here, you get a negative T star. And over here, you get a positive T star. We're looking for this upper T score, okay, for our distribution. Now, anything below that is going to help us with the area. So remember, the area here is going to be anything below that upper T score. If we know 95% is in the middle, that means that 5% is evenly split up in the two tails. So 5% divided by 2 is 2.5%, or 0.025. So here we're going to take this 0.95 area, we're going to add it to the 0.025 area, and that means our area here is going to be 0.975, not 975. Degrees of freedom, remember degrees of freedom is going to be sample size minus 1, which is going to be 23 minus 1, which is 22. So we need to use a 22 degrees of freedom, paste, enter, and we're going to get an approximate T star value, and I'm going to erase this curve, of 2.0738. You guys only need to round to a few places. I would say cut it probably there, so maybe change that to 4. So 2.074, about 3 places is good. All right, so let's switch back over to our confidence interval. All right, so we're going to put that 2.074 here. And now you can calculate this interval. So we can calculate the interval. Now you can do it by hand, but remember, we can do it very similar to what we did. Oh man, I messed up my stuff. All right, well, you guys kind of remember where we were at. 4.9 plus or minus 2.074. Let's do square root of 1.12 over square root of 23. So technology doesn't work for you, right? And let's go see how we can find this in the calculator real fast. Right, remember we can go to stat and then we can go over to tests and we're going to go down to number 8 for T interval. So number 8 for T interval. We did not type our data in to the calculator, but we did use the statistics that we were given from the problem. Recall that our mean was 4.9, our standard deviation was 1.12. We had a sample size there of 23. We're doing a confidence level of 95%, so just basically changing all the options here. Then we're going to go calculate this very quickly, and we get a interval between 4.4157 to 5.3843. I'm going to round here to 2 decimal places when I switch this over. So our interval, as a result, is going to be 4.42 to 5.38. So we can finally say that we are, for our C part, this is our I part, by the way, we are 95% confident that our estimation of this mean, so we're 95% confident that the interval from 4.42, and now here you got to remember units, parts per million, to 5.38 parts per million captures the true mean lead level of crows in the region. All right, this concludes our video for today. I hope that this helped you practice for your test that's coming tomorrow. Watch this on any speed. If you need to slow me down, slow me down. If you need to speed me up, speed me up. If you want to skip ahead to questions that you just want to focus on, do that. If you want to watch it all, watch it all. You don't want to watch it? Well, shame on you because I just spent an hour. Hey guys, once you see this, an hour. Oh yes, can't touch there because then I'm going to break the video. But anyways, that's 56 minutes. When you think that Mr. Bird doesn't love you, I just want you to know that he just made you a 56-minute video. All right. Good luck studying. See you tomorrow. Until next time.